transfer function, I think. Previous session we have solved this example up to maximum part I have reduced into a single block, and finally you have to get the transfer function. Okay, so this was the example seen in the last class. The given block diagram, and we have to reduce this into a single block using block diagram algebra or block diagram reduction rules. Okay, the first we have what we have seen. So if there is any series connected elements or cascade connection, so merge that one into a single block. So simply using that rule, first rule, merging G1, G2 to a single block just by replacing G1 into G. Okay. Similarly, the next one, if there is any parallel blocks, these two are connected in parallel. That means one is takeoff point, one end of the block is takeoff point, the other end is summing point. Then these two signals. If we observe, same input for this block and this block also same input. So in this case, we can use the formula 2, that is G3 plus G4. So we can add these two blocks. Okay, instead of these two blocks, we can directly write one block whose transfer function is G3 plus G. Okay, once we get this, next step, moving this takeoff point after this block. So when we move takeoff point after this block, so an additional block is added at this takeoff point, okay, whose value is 1 by G5. That is rule number 6. Okay, rule number 5. So when we move a takeoff point after this block, an additional block is added at the takeoff point whose value is 1 by G5. Okay, just I have moved. Now again, so once we move this one, so we can eliminate this feedback in step 4. So this is already G3 plus G4. So we have replaced this block, this takeoff point to this point, so that the forward path transfer function becomes G3 plus G4 into G5. That is forward path transfer function. Feedback transfer function is H3. So with the negative sign, so we can eliminate this H3 feedback just by replacing by G by 1 plus GH form. Okay. So once we reduce that one, again merging, eliminating this feedback, H1 feedback, just by using the formula G by 1 plus GH. Cascade these two blocks, and finally eliminate this entire feedback. Okay, that's what we have seen in the last class. See here, the first step, cascading these two and adding, eliminating parallel paths. Next, moving a takeoff point after this block, 1 by GH is added, okay, at this point, okay, in feedback or at the takeoff point. So again, these two are cascaded, eliminated this H1, so G by 1 plus GH1. Okay, again, if we observe this one, eliminating this H3 feedback. Okay, so eliminate this H3 feedback. So you will get these two, eliminating H3. So, and we can replace with, again, using the same formula G by 1 plus GH. So we can replace these two blocks with a single block. Okay, in that case, there is no summing point, because whatever may be the signal entering at this point, it is entering into this point. There is no need of using this summing point directly. We can eliminate that one. Okay, just simply put arrow mark, cascade these two, and eliminate this positive feedback. Okay, I think in the last class we have seen up to this part. Okay, here, so merging two blocks, the entire thing becomes G. Okay, now in this case, this is entire thing is G, and this one is H. If we assume like that, H and G, using the same formula G by 1 plus GH, in this case, because it is a positive sign, so positive feedback, we have to use negative sign here. You get GH. The overall transfer function becomes G by 1 plus GH. Okay. That we have to observe whether it is a positive feedback or negative feedback. If it is a positive feedback, in the formula you will get negative sign. If it is a negative feedback, you will get positive sign. Okay, unless otherwise specified, most of the cases will have negative feedback. Okay, so here this is a special case, that's why it is given as positive sign. Okay, so otherwise, in most of the cases, the feedback is negative. It is having some advantages. That's why it is most of the cases that is given as negative feedback. Okay, next. Again, eliminating this feedback, you get the entire transfer function as like this. Okay. Now our transfer function model means output by input. You will get transfer function model. Don't forget to write transfer function model. This is block diagram reduction. Up to this part, the entire block diagram, complex block diagram is reduced into a single transfer function model. This is a block diagram, a reduced block diagram model. But transfer function model means simply writing output by input that I have not represented in the question. If the question is something like this, reduce the block diagram. Okay, so up to this part it is okay. But obtain the transfer function from the block diagram means finally we have to write y of s by r of s is equal to this entire thing. Okay. Okay. So transfer function model means finally we have to represent like this: y of s by r of s, that is output by input, Laplace transform of output by input is equal to g1 g2 g5 square into g3 plus g4. Okay, whole divided by entire thing. So you will get 1 mark if you represent like this. Otherwise, out of 7 marks, you will get only 6 marks. If the question is a transfer function model, in that case, we have to represent like this: y of s by r of s is equal to. Again, we have to write this one. Don't forget to write that final answer. Okay. Reduce the block diagram means up to this portion. Okay, it is okay. You will get full marks. But if they ask transfer function model means we have to write represent. We have to show in this fashion only: y of s by r of s is equal to something of same thing. Okay. So that is the final equation. If you have any doubts, you can raise. Otherwise, we can try to solve one more example based on the block diagram reduction rules. Okay. Again, in this case, obtain the transfer function of the control system whose block diagram is shown in figure using block diagram reduction technique. Okay, so we can get the transfer function model using Mason's gain formula. One more method is also there, that is using Mason's gain formula. We can get this transfer function. Here it is using block diagram reduction technique. This is one more technique. Here what we are using, that is block diagram reduction technique. Okay. So if it is not given, so obtain the transfer function for a control system whose block diagram is shown in figure. If it is given like that, if the question is asked like that, so in that case, we can use signal flow graph method, or simply signal flow graph, or Mason's gain formula. Using Mason's gain formula, we can get the transfer function model, or by using block diagram reduction method. Any one we can use to get the transfer function model. Okay, now note down this example and try to solve this one. Anybody can respond. First step, what we have to do in this block diagram to reduce into a single block. Anybody, either in chat room, or you can directly switch on your mics and you can tell the answer. First step, I have already represented with dotted lines. Nobody is ready to answer. Draw this figure and try to reduce that one. Anybody? How to reduce the given block diagram? First step, anybody? Out of 33. The first step is reduce this forward path. These two paths are parallel paths. Okay, just if we observe, these two paths are parallel paths. Takeoff point and summing point with negative sign. So we can replace those two blocks with a single block whose transfer function or gain, that can be called as gain. That is with the G2 and the G2 minus. Now this entire thing can be replaced with G2 minus G3. Now once we replace this with G2 minus G3, and if we observe G1 and G2 minus G3, they are in cascade connection. We can merge those two blocks. That is step 2. Okay. Next, step 3 is moving summing point ahead of this block. In that case, okay, a block is added at this summing point whose gain value is 1 by H2, because it is moving ahead of this block. That's why a block is added at this summing point with 1 by H2. Okay, these two can be added simply. merging the blocks, or we can split those blocks, or we can interchange these two blocks, summing points. Sorry. So we can merge these two summing points, or we can split these two summing points, or we can interchange these two summing points. Okay, rule number 8. Okay, using rule number 8, we can just, now the block is something connected in this fashion. So reduce this feedback, and now the feedback is, so transfer function, and we can eliminate feedback H1. Similarly, we can eliminate G2. Finally, you will get a single block. Okay, let us try to solve this example. The first step is block G2 and G3 are in parallel. So I have eliminated the parallel paths and replaced with a single block, that is G2 minus G2. Please note down this figure. Note చేయాలి ఫిగర్స్ అన్ని కూడా. మీకు ఏమైనా డౌట్స్ ఉంటే అడగండి. Block diagram reduction is very important and very easy. Hardly 4 to 5 rules. Once we can able to remember those 5 rules, so we can reduce the entire complex block diagram, any complex block diagram, into a single block. Next step is merging these two. Block G1 and G2 are in cascade. Again, try to draw that one figure. So we have to draw figures one after the other very neatly. Otherwise, you won't get full marks. Okay. Okay. Next, so we have cascaded these two blocks into a single block. Next, what is our aim is to move a summing point after the block H2. Moving this summing point, this is the summing point. I'm moving this summing point after this block. Okay. So the next step, moving the summing point after the block H2. So in this case, if we observe, so I've moved this block. Okay. So in this block, see here, a block H2 is added. Okay, we have to observe that one. So in this case, if we move a block after this block, okay, previously I have told that 1 by H2 is added, but it is not 1 by H2. H2 block is added here. So if it is moved to this portion, a block H2 is added by H2, because if we consider this path from this point to this point, this is in forward direction. This summing point is moving in forward direction only. So when a summing point move after a block, okay, it is not ahead of a block. It is not moving in reverse direction. It is moving in the same forward direction. So that's why, so when a summing point is moving after a block H2, a block H2 is added at the summing point. Is it clear? When a summing point is moving forward direction, H2. If it is moving in reverse direction, 1 by H2. Okay, this is not. So this path, if we consider, that is a forward path direction, it is moving in the same path direction only. Okay, that's why I have represented like this. H2 is added. Same sign, negative sign previously. Now it is also negative sign. So now these two can be cascaded. These two can be cascaded. Okay. So redraw the figure. Is there any doubt? If you have any doubts, you can raise your doubts. Okay, next. So now these two are in cascade connection, these two are in cascade connection. We can merge these two blocks, or we can interchange these two summing points, or we can merge these two summing points. We can split those two summing points. Okay, anything can be possible with summing points. Okay, now the blocks G2, G4, H2 are in cascade. Also the blocks H1, H2 are in cascade. Now something like this. Now again we have already drawn this figure, so no need to draw again. Now I want to interchange these two summing points. See here, interchanging summing points. So we can redraw the figure in this fashion. Okay. So here, if we interchange the summing points, so if we just merge these two, okay. So in this case, H2 and H2, okay, signal. So that is the total signal. If we assume A, this is B minus B. So A plus minus B is added with a negative sign. See here, if we assume some signal A is entering to this, here B is entering. Okay, finally you will get A minus B signal here. Okay, with a negative sign. Okay, here if we assume a unit signal, so finally you will get one unit signal with a negative sign minus of A minus B. Okay, so here one more negative signal. Otherwise we can treat it as positive and put minus plus here. Okay, we can interchange the signs. Is it clear? So now the same thing I have applied. So interchanging the summing points. Finally, if we observe, so G4, H2 with positive sign, H1, H2 with a negative sign, you can split these two summing points. Okay. If I see the same, you will get the same answer. The same signal at this point. So again, eliminating this feedback, here forward path gain is unit value. So forward path gain is unit value in this case. So we have to assume a block whose gain value is unity. So 1 by 1 minus G, sorry, these two are in parallel paths, not the feedback. Here it is forward path. This is forward path, and this is also a forward path direction. Directly we can add, because positive sign, we can add these two forward paths, and that can be replaced with 1 plus G4H2. So this is a feedback. So eliminate the feedback using the formula 1 plus GH. Okay. Once we get a single block here and here, those two are in cascade connection. Finally, you will get a single block or simply a transfer function. Eliminating feedback, this is not feedback. One is feedback and other one is forward path. Just note down this one. Feedback H1, H2, and forward path G4, H2. So one is forward path, the other one is feedback. Note down that one. And you will get 1 plus G4H2. And here, if we apply the same formula G by 1 plus GH, you will get the entire block. So 9th class అయితే 9:30 కూడా ఎంటర్ అవుతున్నారు. మీకు రియల్ గా ఏమైనా ప్రాబ్లమ్స్ ఉండి ఒంట్లో బాగోపోయినా, మీకు ఒంట్లో బాగోపోయినా, సరౌండింగ్స్ లో ప్రాబ్లమ్స్ ఉన్నా, మీరు జాగ్రత్తగా ఉండటం, లేట్గా మీరు క్లాస్కి అటెండ్ అవుతాం. ఇట్స్ ఎ జెన్యూన్ ప్రాబ్లం. Okay. So now combining those two blocks, and finally you will get a single block, something like this. So that is a single block. Now the overall transfer function is simply, we can write it as C of S by R of S, or C by R, output by input, is equal to same thing. So we can represent in this fashion: G1 G2 minus G1 G3 plus G1 G2 G4 H2 minus G1 G3 G4 H2. Okay. So in the denominator, 1 plus G1 G2 H1 H2 minus G1 G3 H1 H2. Okay. So that is overall transfer function. If you have any doubts, you can ask regarding how to reduce this transfer function. Okay. So in a transfer function model, in most of the cases, you won't get G1 square, G2 square, G3 square like that. Okay. So in a transfer function, most of the cases you won't get G1 square, G2 square, G3 square, or something like that. Okay. Except in a particular cases. You won't get transfer function model as G1 square, G2 square. Okay. So if you have obtained G1 square, G2 square or so, the final answer, so we have to go through the procedure again. There may be any mistake. Okay. Next, try to solve this example. Obtain the transfer function model by the block diagram by using block diagram reduction technique. So note down this example. The next class we are going to discuss about signal flow graphs and Mason's gain formula. Using Mason's gain formula, we can get the same signal, the same transfer function. Okay, we can apply Mason's gain formula or signal flow graph for the same block diagram, and we'll get the same answer. Answer is same, but methodology is a little bit different. In a single step, you will get answer. Okay, so let us discuss this one. The first step. So if we observe, there is no cascade connection and no parallel connections. Okay, so in that case, so if we move this takeoff point in this direction, that means this is forward direction, in reverse direction ahead of the block. So that means a block G2 is added when a takeoff point is moving backward direction. So a block G2 is added in the feedback. So in that case, so these two blocks can be cascaded and this can also be eliminated. So forward path. So finally you will get G4 into G2 plus G2 into G3. G4 plus G2 into G3 we can reduce. That is the first step. Let us discuss that one. Moving a takeoff point ahead of the block G2. So in this, I have moved in this direction. A block G2 is added in the at the takeoff point. Okay. So here block G2 is added at the takeoff point. So I have moved from this point to this point. Now these two are connected in cascade, and here it is. That can be this forward path can be eliminated. Okay, we can reduce these three blocks into a single block. So if we move a takeoff point ahead of the block. So next, the blocks G2 are in cascade, block G2, G3 and G4 are in parallel. Now the final answer is something like this. Okay, cascading and eliminating the remaining. Now again, if we observe this block diagram, so there is a problem with this takeoff point. We can move a takeoff point after this block. We can move takeoff point after this block. So if we move in that fashion, we can eliminate this feedback H2. Okay. So and then merge with the G1. And again we can eliminate this feedback. And again eliminating feedback. And again we can eliminate this unit feedback loop. Okay. So if we move a takeoff point after this block. So if we move takeoff point after this block, in that case, a block 1 by G2, G3 plus G4 is added at the takeoff point. So if we move in this fashion, in this direction, forward direction, a block 1 by this block is added. The block is added at the takeoff point whose transfer function is 1 by G2, G3 plus G4. Okay. The same thing. Note down these figures. Okay. Now moving takeoff point after the block G2, G3 plus G4. G2, G3 plus G4. So in this case, see here, the block 1 by G2, G3 is added at the takeoff point. We can match all these takeoff points. So first step, we can eliminate negative feedback. So we can eliminate this feedback into a single block. Next, G1 and this entire thing are in cascade connection. We can match these two blocks. Again, for that entire thing, G2H2 by G2H2 plus G3 becomes feedback. So this becomes H and this entire thing becomes G, G by 1 plus GH again. Okay. So simplifying the inner loop. So inner loop means this is inner loop and also inner loops. So eliminating H2 and eliminating this one. Finally, you have to get this block. So outer loop is with unity gain. Okay, this is a feedback whose gain value or whose transfer function is unity. If it is shown like this. Okay. In between these two, if we want, we can use a block with unit value. Okay, if it is needed. In this case, there is no need. Okay, so simply we can add so after simplifying the inner loop, so the transfer function becomes like this. Now this is entire thing is G and unit feedback H is taken as unit value and again apply the same formula G by 1 plus GH. In this case, H becomes unit value. So that's why the overall transfer function in this entire thing can be replaced with this one G by 1 plus G. So because negative feedback, so in the formula we have to use positive sign. Note down this one. Sir, can you explain inner loop again? Okay. So inner loop means in this case, this entire thing we have to assume it as G and this as H. Negative feedback. Same formula G by 1 plus GH. Okay. Up to this part. This is called inner loop. One inner loop. So you will get value G2, G3 plus G4 by 1 plus G2, G3 plus G4 into H2. So just by eliminating this one, we can replace with this entire block. Okay, that is in cascade with G1. So that means, again, if we write, we can match those two and you will get a transfer function in this fashion. So up to this part. Okay, so we can replace this entire thing with this block. Okay, now this becomes G. This entire thing becomes H. Again, try to use the same formula G by 1 plus GH and try to simplify that one. So finally, after reducing, okay, G by 1 plus GH, reduce the entire thing. So you will get this. Okay, I have simplified everything. So try to solve. You will get the same. Is it clear? Number 207. So try to solve. సాల్వ్ చేయడానికి అంత పెద్ద ఏం లేదమ్మా, సింప్లిఫికేషన్ జాగ్రత్తగా చేయాలి. మనం యూజ్ చేసే ఫార్ములా ఎప్పుడు కూడా G/1 + GHA టు ఎలిమినేట్ ఫీడ్బ్యాక్. దట్ ఈస్ కాల్డ్ లూప్. అంటే ఒక ఫార్వర్డ్ పాత్, మళ్ళీ టేక్ ఆఫ్ పాయింట్ నుంచి మళ్ళీ వెనక్కి డైరెక్షన్ ఉంటే, వెనక్కి పాత్ ఉంటే అది కంప్లీట్ గా ఒక లూప్ కింద మనం తీసుకుంటాం. ఫార్వర్డ్ పాత్ డైరెక్షన్ అండ్ ఫీడ్బ్యాక్ డైరెక్షన్. అగైన్ ఇట్ ఈస్ ఎండింగ్ విత్ ఏ సమ్మింగ్ పాయింట్. స్టార్టింగ్ పాయింట్ దగ్గరికి వచ్చేస్తుంది. సో దట్స్ వై ఇట్ ఈస్ కాల్డ్ యాస్ ఎ లూప్. Signal is going forward direction, again coming backward direction. So that entire forward path and feedback, that combination is called as loop. Now after simplification you will get this transfer function. Okay, and again one more loop, that is feedback path with unit gain. So you will get, again using the same formula, in this case instead of h we have to use 1, and instead of g, this entire thing, g1 g2 g3 plus g1 g4 by this one. Okay, is it clear? Next, simplifying that loop, single loop, that is unity feedback loop. So again after simplification you will get, you have to get this formula, this equations, okay, or this transfer function. Now the transfer function is C/R is equal to output by input. So that is our final transfer function. Note down this one. If you have any doubts, you can raise. Let us discuss the doubts.